Morning, everyone. Afternoon. Welcome to the technical stream. I hope everyone can hear me okay. Otherwise, please send the comments. My name is Pallav Shah. I look after the cloud business unit here in Australia. And we're just going to wait. Cool. And we're just going to wait for a couple of minutes whilst we get the team from the main auditorium to the technical stream. And we will continue with our first guest speaker. Whilst we do that, can we get everyone to please the most important thing? Um, and focus on entering the um, uh, uh, spin and win the draw, right? So, sorry, I was having dual screen, so I've just corrected that. So, can everyone please make some time, make sure that they enter the spin and the win draw, and there are some cool prizes. So we got for the technical stream, we got the prize Jabra Elite 75T. True wireless headphones, and overall there is another draw for the Bose SoundLink Revolve 2 portable Bluetooth speaker. Okay, so we'll just give a couple of minutes, 11:40, and we'll have our first speaker, Eric, take you through the cloud checker. So Eric Morrissey comes from the Cloud Checker. He's going to focus on security compliance demonstration within Cloud Checker optimization tool. And he's going to take you through that demonstration in detail. We'll give it a couple minutes. Make sure you spend some time to enter the draw so that you can win the cool prizes and make the most out of this event. For those of you just joined just then, again, morning, afternoon, based on where you're located. We're just waiting, giving people a couple of minutes before they could join the technical stream coming over from auditorium. And whilst you do that, please make sure you enter the draw and spin and win. And there are some cool prizes for the technical stream. Okay, so it's 11:40. I just want to make sure that we are on time. We've got 20 minutes for each speaker. So I would like to welcome Eric Morrissey, our senior system sales engineer, and he comes from Cloud Checker. Over to you, Eric.
Great. Hi, everybody. It's nice to be here. My name is Eric Morrissey, just like Pallav said. Thanks very much for the introduction, Pallav. I'll say good morning. I'll say good afternoon. I'll say good evening for myself. I work out of the eastern coast of the United States, so it's evening my time, but it's a nice evening to be spending with you guys. So my job is to provide you with an overview of CloudCheckr. I know that CloudCheckr is familiar to a lot of the people on this webinar as a cost reporting, cost analytics, maybe a cost optimization software. But today we're actually going to focus on some of the pieces that that extend outside of that realm and more into security and compliance. If I had to if I had to describe CloudCheckr to somebody who was brand new to the tool, I would say CloudCheckr really is a multifaceted platform. Cost analytics and cloud and cost optimization is one thing, but really CloudCheckr is about a kind of broad consideration of what it means to be an effective, efficient, and secure cloud user. So just to lay the absolute foundation for anybody that maybe doesn't even know what CloudCheckr is, CloudCheckr is a SaaS tool. It is built on AWS infrastructure, and it is designed to gather information from public API endpoints made available to us by the public cloud providers, so namely AWS and Azure. Gather information and use that information to help organizations maintain visibility into what they have, how it's being utilized, how it's configured, what they're paying for those resources, but then ultimately take that information and turn it into better behavior, actually turn it into actionable insight so that organizations, like I said, are running the most secure, efficient, and effective cloud environments. So why don't we get into the presentation here. I'm actually going to keep it relatively short with the PowerPoint slides because we're going to see a live demonstration of the CloudCheckr tool on a demo environment that CloudCheckr maintains. So CloudCheckr, like I said, multifaceted. You might be familiar with some of the billing and chargeback features, some of the visibility and inventory features. What we're going to focus on today is we're going to talk primarily about security and compliance. We'll talk a little bit about automation and remediation, but under the CloudCheckr umbrella, there are a lot of different responsibilities within an organization that might find use within our tools. But today we're going to focus mainly on the tools that I think would probably be useful for somebody in, a SecOps, a DevSecOps role. So I think of CloudCheckr security functionality kind of falling into a few different categories. The first of which is just ensuring that the configuration of your cloud environment is something that is supportive of a strong security posture. So in other words, we want to make sure that the configuration of our resources is not leaving us vulnerable to whether those just be misconfigurations, mistakes, configurations that are dangerous, leaving us vulnerable to data breaches or some kind of destructive attack. So CloudCheckr is going to make sure that the configuration of things like security groups, things like networking resources, access policies for specific resources, or storage resources are set properly. We want to make sure that even things like logging mechanisms are set up correctly. And that information is routed properly to the places that really badly need it to direct action. We also want to make sure that as activity is taking place within the environment, so under this activity monitoring section, that we have a good way to parse and actually respond to it. So CloudCheckr can help us with log aggregation. It can help us with kind of logical analysis of logs, like something like, say, CloudTrail. And then help us with identification of resource change, activity from specific users, things that we think should probably warrant some kind of investigation or response. Now, the other place that I think CloudCheckr is really strong with its security functionality is the application of those tools against regulatory compliance frameworks. And we're actually going to see this in action in just a few moments, but we have some reporting in CloudCheckr that will take the tools that CloudCheckr provides to its users and actually provide feedback on how the use or basically whether somebody is adhering or not adhering to specific recommendations, how that affects their compliance posture. So CloudCheckr will apply that to a number of different compliance frameworks. And actually, like I said, we'll see that in action in just a few moments. And in some cases, I'll point this out when we get into the demonstration, CloudCheckr can also help with the automatic remediation of problems. So not just identification, but in some cases, CloudCheckr will actually say, hey, this is a potential problem. And instead of just telling somebody and waiting for them to fix it, CloudCheckr can fix it for you. So I told you that the slides would be getting super short because this is a tech stream. We want to see the technology. So let's get right into it. So here it is. I have a handful of features of CloudCheckr pulled up for us so that we can get through them quickly. You will probably notice that CloudCheckr's tool suite is significantly broader than what we're going to see right now. There certainly aren't only 6 reports in CloudCheckr. I think it's actually probably closer to 200 or more. But we're going to take you through the hits, the things that people use the most, and the things that really make a super strong impact within our customers' environments. And this one that we're looking at right now is probably my favorite tool in CloudCheckr. The best practices are, to put it very simply, a rule set. So CloudCheckr goes out, it gathers information about what resources are out there. So it'll do direct describe calls against specific services. It will go out and gather CloudTrail logs. We mentioned that CloudTrail or CloudCheckr can act as kind of a logic engine for some of that stuff. It'll go out and gather utilization metrics and all of these different things. And there's lots of generalized reporting in CloudCheckr that can help you search through that on your own. But this tool right here is probably the most effective at taking that rich data set and turning it into something that is super, super useful for cloud operations organizations. It's a set of programmatic checks that CloudCheckr is going to make against all of that information that it's gathered about, an AWS account or an Azure subscription. That's another option with CloudCheckr, and tell you, these are the things that we think are wrong. This is how you fix them. And, not just run like a single audit so that, you have a list of things to take care of and then you're done. It's something that CloudCheckr does consistently. CloudCheckr, all of CloudCheckr's data collection is built on a scheduled polling process. That means, you're not just going to find out the one time that you run CloudCheckr in your AWS account when you have, say, a publicly accessible S3 bucket. CloudCheckr is going to tell you when it runs its discovery, every time, multiple times a day, when something like that arises. So the way that we organize this, and you might see already that the list of checks that we can run is very, very long. We are well up over 600 best practice checks that we can run now across a bunch of different categories: security, cost, availability, usage. And we'll even see some of the checks from native services as well, things like AWS Trusted Advisor, things like Azure Advisor, Azure Security Center. Those get brought into our dashboard alongside all of the ones that CloudCheckr runs proprietarily. So what I mean by that is Trusted Advisor can provide you with, say, 100 or so checks to help you manage everything across security, cost, availability, and usage. Whereas CloudCheckr has, like I said, well up over 600 checks, and even just in the category of security, probably close to 300. What this means is that you can still use Trusted Advisor if you like it. If you're getting good information out of it, that's fine. CloudCheckr just provides you with an opportunity to significantly increase the detail with which you can set organizational standard for configuration and then monitor against it. So this list of checks includes things like publicly accessible resources. Here's a good example right here: publicly accessible RDS-DB instances, storage resources. Maybe it's a database, maybe it's an S3 bucket, something like that. CloudCheckr wants to make sure that a potentially problematic configuration, like that being publicly accessible, is called out. There might be good use cases for that. There's always a chance of that. So CloudCheckr will tell you exactly what it's looking for, why we think it's important, what we think the kind of overall impact level is, and then it'll tell you if we think there is an easy remediation path. It'll tell you exactly what that is, and it'll provide you with links to documentation, or AWS documentation if we think that'll help. Provide you with links to more detailed reporting in CloudCheckr that'll tell you more about this specific resource. And then when it's time to respond to something like this, we can either use what CloudCheckr calls its fix now or its request fix buttons, this right here, for to actually initiate a remediation of this problem. So in other words, CloudCheckr will reach into the account and switch in this case, the publicly accessible flag from true to false for this resource. Or if we actually think that this is intended function, that's fine. We can hit this little ignore button right now. CloudCheckr will remove this from my primary dashboard. And I won't see it and feel like I have to respond to it. Obviously, anything that you ignore, you can still audit. It doesn't go away forever. Helps with kind of building in exceptions to rules like this, as well as just kind of paring down to a set of recommendations that are consistently actionable. we've reviewed something like this, we think, hey, this was really useful information. I'd rather get it in my email inbox when something like this is discovered, instead of having to come and find it in the UI. Or maybe I want a Slack message when something comes up, or I want a ticket created in Jira or ServiceNow. That's another option, and can really help operationalize some of this stuff and turn it into, instead of just a to-do list that sits around waiting for somebody to log into CloudCheckr and review everything. Now it's something that works along with your existing change management processes. Now, the rule set as it exists, it's configurable. You can take things that you like, take things that you don't like, and remove them, shape, mold this, sharpen this into something that, like I said, is consistently actionable and is actually working along with your security strategies. Now, a lot of people might look at a list this long and say, well, this is hard to digest. I don't know what to action on here because there's just too much. What I often say to those people is, well, let's think about business goals. And for a lot of organizations, that will probably come from some kind of mandate or a business need to adhere to a compliance framework. So CloudCheckr's total compliance module down here can actually help them take the best practice checks and map them to specific controls within compliance frameworks like CIS. CIS gets its own report because CIS actually writes its own documentation with AWS. They have the AWS foundations for CIS written out that really specifically lay out what you're supposed to do with AWS and what you're not supposed to do. But there's a lot of compliance frameworks out there that don't have such specific controls. And for that, we have another report in CloudCheckr called the Total Compliance Report. So you got your CIS report or your CIS benchmarks report, and then you got your total compliance report. And this is where CloudCheckr actually maintains some of its own documentation and mappings between compliance frameworks and our best practice checks. So we'll tell you, hey, here's the compliance framework. Here are all the controls under this compliance framework. And of these controls, here are the ones that we think we can actually help with. And here are the best practice checks that we think can get you closer to compliance against this control and therefore this compliance framework. So I would come in, I would open up this, say I was interested in NIST 853 compliance. I would come in and I would look at some of these controls. I would start with this one, maybe principle of least privilege, and start looking at all of these users and groups roles with full admin privileges. I could go through, respond to these, and as I actually resolve the problem, this would go from no to yes, and my actual score here up in the percentage bar of the compliance report would go up. As you can see, this account not doing particularly well. So from here, CloudCheckr has, we're in the total compliance module now. We have a security module that adds a number of ancillary tools onto this. So even more kind of configuration, like targeted configuration reports, something like this perimeter assessment report is useful in identifying where publicly accessible resources are. I can actually have CloudCheckr just filter out the things with some kind of public accessibility to it. I can scroll through all of the regions that have something that is publicly accessible and then have CloudCheckr identify for me exactly what it is and where it resides and provide me with links to more detailed reporting. So again, I can make better decisions about what's supposed to be publicly accessible and what's not. We have other configuration reports in here that target administrative permissions attached to IAM users. We have reports that just provide kind of overall inventory on the resources that actually govern security within our infrastructure. Things like your security groups, things like your VPCs, the different sub resources or the elements that sit on that networking framework. Basically, everything that you would need to get a clear picture of your perimeter and your configuration and the security of it. From there, once we know that our configuration is relatively secure, we want to know if there is some kind of deviation away from that. I think one of the most effective ways to do that is to alert on specific actions that we think might be problematic. So I mentioned before that CloudCheckr can act as an alerting mechanism for CloudTrail. We can basically route our CloudTrail logs through CloudCheckr. CloudCheckr will provide us with a number of built-in alerts that we can use to basically just, one click turn on and have CloudCheckr start sending out notifications to some kind of notification path about something that we think might be dangerous. But we can also build our own. We can go into this new alert section. CloudCheckr will say, okay, where do we want to send this to? We want to send it to an email address. We want to send it to a Slack channel. We saw some of these notification paths before. Slack, Jira, ServiceNow, Syslog, PagerDuty. What's unique about the security alerting is that we can also send our security alerts to Lambda. So if you had a scripted response that you wanted to happen in when CloudCheckr discovered one of these events, then CloudCheckr can facilitate that. Then we decide what the actual parameters are of the event that we want to trigger the alert. We can get all the way down to a specific event name. We can use the built-in alerts as templates to start from, and then cross-reference against things like regions and services, and then get down, if we really wanted to go crazy, firing thresholds and resource filtering, string filtering on request parameters and response elements. Lots of different options to really target this and filter out excessive noise. So then from there, we've got our configuration set up relatively strongly. We've got our alerting set up. Now we want to know if there is, if there is activity that we need to analyze, change in our infrastructure. Basically, if we need to do historical reporting for some kind of root cause analysis, then CloudCheckr can help with that too. We maintain quite a bit of historical data across all of our reporting in CloudCheckr. We guarantee up to 3 years worth of historical data in the application, and then another 4 in archival after that. And what that means is that everything from your compliance reporting up through things like this, change monitoring, means that you can go back and really clearly see, what new resource was created, what was modified, what was removed, who did it, where did they do it from, and you can really do that for a highly customizable time period. And I haven't mentioned this before, but obviously if you need to do external analysis for any of this data, you have your options up here in the top right. Pretty much every page in CloudCheckr has at least a CSV and a PDF export, and CloudCheckr also has its own REST API. And so I think almost everything that we've talked about today is not only available in the UI, it's also available via API for anybody that wants to get the data programmatically. All right, I got my eye on the clock. I'm down to less than a minute now for my presentation, but I think I kind of hit my target here. Like I said, there are literally hundreds of reports of CloudCheckr that we have not talked about today. I know that cost analysis and cost optimization is near and dear to the Westcon users that actually interact with CloudCheckr on a day-to-day. But if you haven't started using CloudCheckr for security and compliance, please know it can be extremely impactful and extremely useful for anybody that is, that's looking for help in that area. So I just want to say thank you to everybody for your attention, and I hope you have a wonderful rest of the day. Yeah, I hope I get a chance to talk to you more about CloudCheckr when you need some more information. But it's been great talking to you, and enjoy the rest of the event.
Thank you, Eric. Such a great presentation and demo of the product. And by the way, team, if you sign up with Westcon, if you're not a partner, and if you're dealing with AWS, Westcon provides CloudCheckr as a product that we can optimize your networks, right? So thank you very much. Right on time, Eric. Our next guest speaker is Salman Abbas Saeed from F5, and he's going to take us through securing modern business critical apps in a cloud ready world. Before I do that, and before I hand it over to Salman, can everyone, just a quick reminder, can everyone please enter the draw, spin and win? Make sure you are part of the potential to win the prizes. They're really good prizes for the tech stream as well as overall. So make sure when you got a moment, you do that. And over to you, Salman.
Thank you.
Salman, you need to enter into full presentation mode, please.
Yeah, are you able to hear me?
Yes, we are. You can continue,
okay.
but you just need
That's
to enter into full presentation mode. I'll just take that out quickly while you get that up.
Yeah.
You had it and then you went out. So just push,
Sorry
go
about
into
that.
full okay, there you go. All righty.
All right.
Thank you.
Sorry for the hiccup. Good morning, good afternoon, everybody. My name is Salman and I work for F5, covering APCJ. And we have been working very closely with AWS to migrate our customers to AWS and ensure that they have the same level of consistency and security policies and what have you, across a hybrid architecture. So my conversation today revolves around a concept called WAP, Web Application and API Protection. So I'll just take you back in time. Before October 2017, Gartner had a Magic Quadrant for WAF, which was Web Application Firewalls, and they were covering your OWASP top 10 attacks, and providing signature-based protection, and so on. But then, with the adoption of cloud and the sophistication of attacks on the internet, in October 2017, Gartner introduced this new category, just because they believed that just having a WAF alone was not enough to provide comprehensive protection. So the web application API protection concept revolves around the fact that there's a proliferation of APIs. Most applications are being accessed via mobile devices, and backend APIs are being exposed through API gateways. And hence, it's very important to protect not just the application, but the APIs themselves, as well as provide bot mitigation, because the number of bots out there is just unbelievable, just because of the just because of the fact that compute has become so cheap that people can actually use that compute capability to actually launch attacks and create botnets and what have you. And at the same time, any comprehensive security solution should have DDoS protection at the application layer as well. So WAF, bot protection and mitigation, DDoS protection and API security are what make a solution complete and able to protect against all sorts of attacks out there. So when we talk about OWASP API security, OWASP has actually shared with us what their vision for API security looks like. So the first pillar is application protection. So of course, we need to be able to inspect the payload and detect problems with that, malicious content within that, right? We need to be able to provide, detect and stop bots and provide DDoS protection, right? The other thing that's essential is to have access control. So, who can access the backend APIs and who can't, right? So some sort of access control, which is provided by an API gateway typically, right? And finally, you can't protect what you can't see. So it's extremely important to have visibility into your APIs through an API management dashboard. So what I'm going to do now is to provide you an F5 view of the three pillars of OWASP API security. So how do we address this and how we align ourselves to these three pillars? So first of all, for application security, we have the F5 AWAF, which runs, as a appliance as a virtual appliance on AWS, right? We have Nginx Plus App Protect, which uses the same WAF engine that F5 AWAF uses, but it's a containerized form factor. So you can protect, with F5, you can protect north-south traffic, and with Nginx, you'll protect east-west traffic. And then finally, we have this solution called Shape, which basically provides enhanced bot detection and blocking. So basically, that's how we covered the application security side of things. When it comes to access control, Nginx offers an API gateway that takes care of all your access control and proxying functions to the requests to the backend APIs. And finally, for visibility administration, Nginx provides API management, and F5 provides dashboards as well, where you can actually monitor your APIs and see what's going on. Now, what we looked at was one side of the picture, more from an infrastructure perspective, right? What infrastructure you need to actually protect your APIs. But now let's look at integrating security into the API development pipeline itself, looking at the code itself. So the whole notion is to include API security as code. So from the time you start coding throughout, as you go throughout the development process, from code to build to test, deploy, and so on, it's important to integrate security here and shift security, what we call, to the left, right? So instead of deploying security right at the end, just when the application is being deployed, you actually integrate security at each step, right? So security is checked in with the code, right? As you build, the security policy is built with the code. When you test with security. You don't just test the software for functionality. You test the security as well. And then when you deploy, the security is deployed with the code. So basically, taking those two things into consideration, our alignment with the OWASP vision of API security, as well as the ability to actually insert ourselves into the CI/CD pipeline for software development from a security standpoint. Here's what F5's WAAP architecture on AWS looks like. So basically, the user could be a mobile user, or or another app, or a web app, right? The entry point would be the F5 Advanced WAF, which would actually inspect north-south traffic and use our comprehensive signature-based database to actually look at the attacks and inspect the traffic and block them, right? We also have campaigns that help you protect against day zero attacks. F5 WAF is fully programmable, so you can actually deploy it as infrastructure as code. You can configure it, with Terraform. So it's fully agile and cloud ready, right? So there's no friction there at all, right? It's completely programmable. And then for fraud protection and bot mitigation and bot detection, we use the cloud intelligence of the Shape Cloud. So basically, we look at the traffic patterns, and based on heuristics, we actually detect bots and block them, right? And on a second layer, as you come into the, as you're about to approach the Kubernetes cluster, or, as you're about to access your backend APIs, we have the Nginx App Protect deployed on the Nginx API gateway itself. That provides you not only access control from an API gateway perspective, but sort of a consolidated WAF functionality as well, right? So this WAF, of course, can be used for east-west traffic as you move from one microservice to another and protect your APIs. And you have a visibility and management dashboard available, where you can actually see how your APIs are performing, who's calling the APIs, and you can do throttling and so on, right? So basically, before any request hits your backend API, it's fully inspected and is known not to be a bot, to be completely secure, non-malicious, so that you can actually you're only using your resources, your precious resources, to serve legitimate requests. Now, for the WAF portion of it, we have F5 managed rules for AWS WAF. So, of course, you have the standard AWS WAF rules, but we also offer managed F5 rules to enhance your security posture, right? So these are pre-configured rules written and managed by security experts, which actually complement the base policy of AWS WAF. And they can be deployed by AWS WAF either on ALB or CloudFront, right? So depending on how you want to, what your architecture looks like. And you have a choice of rules, each providing protection against different attack types. So depending on the attack vector, you can actually choose which rules you want to apply. And the best part is it's a pay-as-you-go. The whole pricing is on pay-as-you-go per hour basis, right? And you don't. There's no sort of heavy lifting. So it's very easy to get started. You simply subscribe and associate with your AWS WAF, right? So that's it. And you get those managed rules automatically. Of course, you can customize. You can you can decide if you want, you're looking for a specific rule, but you get this out of the box basically with a single click and subscription. Now, looking at the Nginx App Protect site, more from a containerized form factor, you can actually deploy this WAF, which uses the same WAF engine. We call it OneWAF that AWAF uses. It's just the form factor is different. That's more of a VM form factor, while this is a containerized form factor. So you can deploy Nginx App Protect as a software load balancer in front of your application. You can deploy it as part of the Nginx Ingress controller, which is the default Ingress controller for a Kubernetes cluster. You can deploy it at the API gateway, which we looked at earlier, and you can also deploy it as a reverse proxy. For example, inside a sidecar container, right? So you have multiple options to secure any deployment design. So just looking at Nginx App Protect again, right? Basically, it's a high-performing WAF and provides security just beyond signatures. Uses the same WAF engine. It's CI/CD friendly, so you can, as we looked before, it's extremely important to insert security into the API development lifecycle. So you can insert Nginx App Protect into that lifecycle, right, in all steps. And uses an F5 declarative interface, so you can actually declaratively configure it. It can send security statistics via syslog to different dashboards, and it's backed by F5 support. And finally, what sort of completes the picture is F5's shape platform for bot and fraud mitigation. So basically, although it may not be visible, or it may not be very apparent or read, fraud and bots have a tremendous adverse impact on your resources and on your, on your finances, because if it's not a legitimate user that is using your application, you are actually using your compute, storage and other resources to serve bot users who are basically fraudsters or just doing web crawling and so on, right? Now, in a cloud world, that means a lot. That means money. that means that is directly tied to money, right? So because it's based on a consumption model. So the more resources you consume, the more you pay. So it's extremely essential for customers that are using AWS or migrating to AWS to have a comprehensive bot protection or bot detection and fraud mitigation solution like Shape integrated into their security stack. So of course it's important for on-prem users, on-prem applications and on-prem architectures, but it becomes even more important for cloud-based architectures. So we talk about the 3 Fs here, right? So it's like a funnel. So basically we first look at fiction. So we separate facts from fiction, right? So we detect bots through CAPTCHA, through other means, through heuristics. And we basically separate fact from fiction, meaning users, humans from bots. That's like the first layer, right? Or even a human click farm, right? So we can detect that it's not really, it couldn't be, it's not a bot, but it's a human click farm. So it's not something which is supposed to be accepted by the system, right? So it kind of, we block that, right? At the second level, okay, so now we know that these are all human beings, right? So at the second level, we differentiate between good customers and bad customers. So we look for, so we, for example, we look for to identify compromised credentials using Blackfish. We have this thing called device ID that actually creates a profile of the user based on their behavior, based on how they access the application, how many clicks they do, where they click, the browser they're using, and many other things, right? And basically we create a profile, and it's very accurate, and it accurately identifies sort of a user who's malicious, who's involved in malicious activities, or who's doing something unusual, from a user who's normally behaving normally and just accessing an application normally, right? So now we have an even smaller set of just good users left. These are users, who are legitimately interested in your applications or accessing your applications, or whether these could be paid user or unpaid users, but we know these are users with good intent. And here we reduce the friction from them, right? So for example, we increase their login timeouts, right? We ensure that there's no CAPTCHA anymore, and so on, right? So that their experience is very good, and that good experience directly translates to increased revenue, right? So basically, in summary, web application API protection is the way to go, or to be considered when you're migrating to the cloud, whether it's AWS or any other cloud. And F5 provides end-to-end protection in line with the OWASP vision of API security. Thank you. If any questions, feel free to shoot them on the chat.
Thank you, Salman, for taking us through this in detail on how F5 fits the whole picture. Look, team, if you have any questions or comments, please shoot it through, and we will take it from there, and we'll follow up with the answers. Thank you very much, Salman, for your time today.
Thank you.
All right, so our next guest speaker is David Wright, who is going to talk about HashiCorp. And before we do that, I just want to take a quick moment. If everyone can please go to the draw and just register themselves, because we've got some cool prizes. So it'll be only taking 30 seconds or less for you to just register yourselves. Once you're registered for the draw, we'll be announcing the prices at the end of it, right? So I'll just give it those 30 seconds, and whilst we do that, I'm just going to introduce our partner solutions engineer for HashiCorp, David Wright. And David Wright is just going to focus on today implementing AWS cost management best practices with HashiCorp Terraform. Okay, HashiCorp is a great vendor, and David Wright is going to take us through that. Over to you, David.
Thanks, Raveen. So, as I said, I'm David Wright. I am fortunate enough to work with our technology and our SI partners to deliver our solutions across our portfolio to our customers. What I want to do, first of all, is obviously talk about some of the challenges and some of the problems that we know exist with cloud spend. Why that happens, how do we get there, and how do we actually take, and what approach can we take to do that? Now, obviously, the cloud platforms themselves have, some great information resources. Some of those that I in the resource pack that I've shared, but there's also an overall approach that you have to think about. So if we just take a look at what's happening, we know due to the pandemic, we know due to digital transformation, that cloud spend is going to grow. There is, in a recent survey, looking towards an increase across organizations as much as 47% increase in spend. But that increase in spend also means that there is going to be more organizations, parts of the organization using it, lots of more use cases. And interestingly, what organizations are seeing is that there is a percentage up to 23% of actual overrun on that first cost comparison of what they thought that it would take them to run the cloud. This is interesting that that organizations see this cost challenge because obviously one of the reasons that they move to cloud is actually reducing those costs. And so if we think about the initial process and where organizations are coming from, people, process, and change is obviously always going to be a major part of that digital transformation. So thinking around what that digital transformation is, how you get to that state and how you can actually be effective comes from usually this background. And so most organizations, and I know my own background, we used to run an ITIL process. A requester would ask for something, a ticket would come out. I was in the infrastructure team. We'd evaluate that ticket. We would look at what it meant. It would have very defined context around what we would do. So does it need to have a new switch? Does it need a new switch port configured? Does it need to be cabled? Does it need, how much power does it consume? And all of these things were actually set up into like a recipe book that had an associated cost with it. That cost would be added up, and either that project or that request had a budget allocation for it, which would mean that it came out of that costing code, or we tied that cost into BAU, business as usual, within it. And depending on what that cost is, what the project was, what it was doing, meant those things were easily controlled and allocated. But it also meant the process was really slow. The process was hard to change, and once stuff went into the field, it was there for the long haul. Now we know with the introduction of DevOps, the underpinning mechanism of that DevOps thinking is infrastructure as code. And infrastructure as code obviously means that now, as we're writing and have the ability to stand up cloud resources using an API first mechanism, we have the ability to write and define our infrastructure as we want. But that also means that you have a lot of power of control. So instead of that process now going through certain criteria, price books, and control, the person writing that and deploying it, if they have the permissions, are spending it. And so this means that that person has to also take into allocation around what they're doing. They have to have an idea of what the impact of those resources are, and they have to understand exactly what it is that they are looking to actually provision. Do I really need this massive server to run my test app on? Do I really need to be like, am I doing this for any reason other than it's the cool shiny thing to do, or am I doing this for it because it has a very clear business outcome that can support that cost? And so that part of control, where you had it in the old process around the price books, having people and peers review what that costing structure was, a lot of that process is taken out when you actually start to implement DevOps and infrastructure as code, unless you put in place those controls. And so if we look at what is happening and why things can get out and how things can get out of control, it kind of then opens up the conversation around, well, how do we then fix that process? And so if we take a look at that journey, first of all, obviously we picked that we're going to pick a platform and start to adopt that platform. We then get the skills necessary to look at how we can actually implement that. It's a small team. That team is obviously responsible for the deployment. They have to set up some accounts, set up who has access. They have to prove what it is that they're deploying, and they drive a proof of outcome for that. And that ultimately delivers the application or the use case that the business put in front of it. And that team is obviously very closely controlling the costs, because part of that application and rollout and move to digital, or the move to a digital transformation has a costing, probably has a costing factor around it. Now, is it cheaper to do it in the cloud? What's the controls and processes? So they're very conscious of that costing component. Then as we mature, so we create this cloud center of excellence. The cloud center of excellence starts to gather a cross-functional team. That cross-functional team uses those same best practices. They use the coding mechanisms. They are very, very diligent around using spin up and spin down and elastic environments. So the costing structure is very, really tightly controlled, and they see a dip in the overall expenditures and maybe even a reduce a business cost from it. So this is starting to see the benefits of what cloud was promising them, and where they think cloud will take them and how it helps their business. They start to roll that out, they start to mature, they start to allow more and more business teams and cross-functional teams to start using the process. More accounts with more privileges get created. There's more dev and test environments that are needed. There are more general application requirements. And so they start to see that costing structure build as expected. So there's, as we start to use it more, so that costs will actually start to grow. But it's all actually at a lower cost than would have been done if we tried to do it on premise, or if we were doing it and being able to turn that around in a faster, more effective time. But as this starts to then scale out across the business and you get more and more teams using it, so more and more accounts get created. So you start to dilute what the initial outcomes and the initial proof of concepts were around. So you get more and more applications, more and more dev components, and you lose that process thinking around what the actual outcomes were. And people are focused on just getting the job done as quickly as possible, not necessarily applying all of the more restrictive elements that fitted in around making sure that costs were contained, making sure that environments were spun down on the weekend, making sure that process control around, well, you can't use that instance because it's too big, starts to slip. And this is where we start to see this increase in costs, and then this blowout around, where did this come from? And so as we progress through this natural progression of a cloud adoption, so the people and process have to actually fit into part of and get control around those spends. Otherwise, you lose control and you lose sight of it. And so how do we do that? Well, AWS has some really good kind of resources that link below, link you through to the white papers around it, that actually defines what we need to actually really focus on, or what you need to focus on around that. So being able to get control of your resources, being able to actually define and make sure that there is cost allocation, and that through to an end team or line of business, making sure that there is a budgetary process review, so making sure people understand what the costs are, enforcing and creating tagging. So this actually ties to that cost allocation. If I tag resources and can drive tagging and enforcing tagging, then I know who's doing things, and therefore, because I know who's doing things, I can allocate a cost to that. And then also having the most optimum architecture, being able to use patterns and deployable patterns like landing zones to be able to then create templates that people can consume easily with a defined cost associated with that. And so if we take a look at how HashiCorp can help, we can do a lot of these elements. We can control the resources, so we can put governance and compliance around it. We can enforce tagging, so resources and process workflows won't run unless they are tagged properly. And when we can put a budget and cost constraint around that by being able to actually define what that is. And so if we take a quick look at that that process and think around where we fit in. So we have governance and compliance around mandatory tagging, being able to put policies in control around instance sizes, being able to define when and where developers or users can actually deploy infrastructure. So you can use only the free tier in development, but you can use obviously production T1 grades in production. We also be able to track and be able to feedback who's done what, when they deployed and when. So we can put and apply infrastructure changes and notifications, so you get visibility into when infrastructure is doing it. And we can also optimize to make sure that when we have the right instance sizes or the right environments, the right times and controls are all implemented around that. And this is all done using our policy as code. So obviously we have infrastructure as code, which is where Terraform comes in, and we have policy as code, which integrates into that using the same programming stanza, which we use in our Sentinel policies. And our Sentinel policy, we'll take a look at a little bit in the demo. And so just from a workflow perspective and where this fits in within the architecture, we really tie this together in that when you have a developer or a mechanism driving the Terraform component and driving Terraform Cloud, within Terraform Cloud for Business, you have the ability to pull in your modules, so your repeatable blueprints that you're using to define your infrastructure. This could be best practice around an ECS deployment. It could be using something like one of the automation and innovation templates that deploys in a complete best practices environment for you. But bringing that module in, running it to deploy and stand up an application. As part of the plan process, we run through a plan, so a preemptive component of what will be applied. Within that, we can look at what the Sentinel policy is. We can define those three things. So we can define that we have, is it tagged properly? Is it using the predefined modules? Does that module actually have a cost associated with it? And is it the right size instance? And what is the overall cost of that module to deploy? We can make sure that that is enforced. And then if it passes that policy as part of the workflow process, we can then apply it and then build out that infrastructure underneath. And so let's just take a quick look at what this looks like in reality. And so what we have here is, this is our workspace. This is Terraform Cloud for Business. Within that, I've created a workspace. This workspace has our code set associated with it. So here you can see we have our code. This is the actual code that will be deployed. And all we're doing is standing up a very simple Ubuntu server. Within that workflow, we have the ability to apply our Sentinel policy. So if we kick off our new run, start our plan here. So this is actually in real time going out, looking to queue up and build that infrastructure. So it's going to and getting to see if that resource can be stood up. It's doing that check. We're going to create this one resource instance. So if we just drill down into what that's doing, these are the things that it knows it can create. So it's got an AMI ID, it's going to provision it. All of these other things will be defined once it's done. It's passed its cost estimation. So if we look at this, we've now associated a cost with it. And this is done through the Sentinel policy that has been associated with this specific workspace. So we know that it has an hourly cost. That cost has a monthly cost, and we've added it up into a delta. So we run that through our policy, and we can see that we've actually defined a policy that says it has to cost less than $100 a month to run, It's past that policy, and so now if we apply that, we could actually stand up and build that infrastructure and build out that infrastructure underneath. And so what you can see from the demo is that we've taken responsibility where we can for the cost management. We took the workflow. We have applied policy as code to that workflow, and that workflow then, when we use it, has a deemed set of structures around it. Now that's defining what the budget should be, who's defining that costing, and what that control is, whether the right instances have been defined, and whether it's the right environment. But that still needs, obviously, someone to approve that workflow and deploy it. You can automate that, so it can automatically deploy up if the policy passes. And we have a clear line of sight of what's been deployed through Terraform Cloud. That can go through and update and email and alert users, so they know that changes have happened. You can have clear insight into what that's been done, and then with that, we can then obviously allow them to go and automate. Now, automation shouldn't be feared. Automation is the key to actually allowing you to be agile, to be able to experiment, to be able to stand up and really experiment and take the best use of your cloud, and multi-cloud or hybrid cloud, whichever mechanisms and platform consumption you're looking at. But you also have to take responsibility, share that control, understand how to put governance and compliance into the workflow, so that as you allow more and more users to actually take on and start taking advantage of the cloud, so that they can have governance and compliance built into that workflow, and they understand the impact of what they're doing. With that, I will hand it back to Pravar and wrap up. So thank you, everybody, for this opportunity to talk to you, and hopefully there was something interesting there for you to or something that you learned.
Thank you so much, David. That was a great presentation on HashiCorp and how it fits the overall picture. We are still waiting for our next speaker. David, if you have any key pointers apart from the takeaways you want to raise with the team, that'll be great. We still have some time up our sleeves.
Sure, no problem. What I would say is that in trying to expand, the use case that we talked about here was very much around automation with just deployment. So this is focused around Terraform and infrastructure deployment. But within the Hashi stack, there's also a set of other products that then also help fit into this. Now, it doesn't necessarily go within traditional cost management in this way, in that you're building this costs X amount to stand up in terms of that kind of light switch capacity using. But it's also important to think around how other services can be integrated together to then allow that control of costs across multiple platforms. So if you're thinking around even a hybrid scenario, if you look at how and what your security standpoint is for, say, secrets management or access security, if you're starting to having to integrate that service across multiple platforms, hybrid or multi-cloud, and you're starting to look at that, then you're using native or multiple tools across that element. And this is where things like HashiCorp's Vault can centralize that control process, and now you have again a single tooling mechanism to be able to work across all of those platforms and allow access. So now we've built in another tool that actually allows us insight, integrates in with HashiCorp, in with Terraform, can be driven by Terraform. And now again, you're having that responsibility around being able to not only control when infrastructure actually spins up, but also who you're giving access to. So as we spoke about there, making sure you have clear controls and integrating those two things together. Thinking around how to tie connectivity into that. So leveraging something like Console, HashiCorp's Console products, where now you have a full suite where you've connected your application, you've secured it or connected an application, you've secured it from a single strip parts, and you've automated its deployment using Terraform. And all those things go together to really build out a solid model that helps attain your digital transformation journey that you're looking to achieve.
Great. Thank you so much, David. I appreciate your time, and it is clear messaging, so that's fantastic. I will now go over to our next speaker, and our next speaker is going to be Sujit Nair, who is our expert from Palo Alto. He is going to focus on comprehensive cloud native security, crafting the journey to cloud securely. So over to you, Sujit.
Yeah, Jiggy, thank you so much. Good morning, everyone. And today the idea, as part of this session, is to quickly talk about what are the trends that we are seeing from a customer point of view, what our customers are doing, or the challenges that they are coming across with the technology evolution that is happening over the past few years, and how Palo Alto can help you, to work closely with your customer, engage across all the different aspects of cloud security, and how to make sure that their journey to the cloud is completely smooth and seamless, at the same time fully secure from all the aspects of the threat vectors in the cloud. So let me just quickly get started, right? Typically, the way we have seen over time is that there has been a major evolution from an infrastructure point of view, right? While almost every customer starts the journey on the on-premise environment with the private cloud in the data center, you know, the when new application or the app modernization initiative starts, we see that there is a transformation that is happening from the compute side. The first thing is, from a traditional VM based approach, we see a lot of adoption of Kubernetes and containers to deploy new applications. While this journey starts, what typically happens is, as the customer starts progressing from the application modernization, a lot of adoption starts moving towards the cloud at the same time. And with the cloud adoption, what we have seen is there are four primary aspects that change in the underlying behavior of the application, the way they are deployed, and that has certain security implications. To start with, right, the first and foremost thing that happens when a customer moves into cloud is to build cloud native applications, which basically means they are using a combination of ES services and PaaS services coming together to build that application, which allows the customer to scale, which gives them the flexibility and agility that is required from the cloud. At the same time, the combination of this helps reduce the cost drastically over time. The second thing that typically we see is the adoption of newer compute services, right? Not just VM and containers, but also the integration of serverless into the mix to make sure that the applications can now function in a much more agile and a faster manner. The third thing we see is, a lot of auto resiliency, auto healing, auto scaling capabilities coming into play, right? Which ensures that at any given point of time, when the application infrastructure is planned, it is more from an minimum requirement to start with, and which can auto scale to whatever customer requirement or the customer demand comes in from an end user access point of view. And finally, a major shift that we have seen over time is the way the applications will interact with each other, starting with an east-west communication using API interface to now even the north-south communication, primarily riding on API to communicate. While all of these changes are happening, from an infrastructure side, it might not seem to be a lot of things, but from a security point of view, this has a lot of implications. The way security has to be planned, the security has to be seen. Let me take one simple example to get started with, right? One of the major shift with the cloud adoption, specifically when you come into AWS, a lot of code, a lot of services and APIs are deployed using, CFTs, Terraform templates, which we call it as, infrastructure as a code. Let's first quickly look at why do we even need infrastructure as a code in first place. When a developer starts building his tool, right, he would create his scripts, he would do the commit into the software repository. It then goes through the entire process of the build, unit test, the integration test, to make sure that there are no bugs, there are no issues with the application. All the functionalities which has been deployed as part of the code is absolutely functioning fine. But once this is done, the next step typically is to deploy it in an environment, right? Let's take, for example, in this case, in the cloud environment, right? It could go into a VM, it could go into a container or a serverless, right? Or a mix of all three of them to run their application. As part of the process, right? Typically, traditionally in the data center, the operations teams were responsible for it. Now, when the situation comes to deploy it, right? While all of the process that today at a development phase that happens are all automated, right? The CI/CD pipeline comes in, which does the, the integration build part of it, and then it automatically deploys it into the cloud. Now, in such a scenario, when the entire software build to deployment is happening in an automated stage, right? When it needs to be deployed finally, from a resource point of view, manual provisioning of compute, network storage, and all other resources that are required, right, becomes a major friction. And that is one reason why this entire model of the traditional approach does not work in the new world, right? You need something from an infrastructure provisioning point of view to be part of the CD pipeline, the deployment pipeline in an automated manner. So when a resource is getting deployed, there are no pre-provisioning of hardware happening well in advance. It's nothing to do with someone manually going and deploying the resources. It has to be part of the entire pipeline, and that is primarily the reason to make it in a seamless manner, a major adoption of infrastructure as a code is happening, and that ensures that all the infrastructure deployment required for an application to function is part of the single CI/CD pipeline. And this approach has been gaining a lot of traction in the market. A lot of customers today rely on infrastructure as a code to deploy their cloud infrastructure, their compute infrastructure, all the necessary underlying infrastructure requirements, right from security, being part of this particular code line, right? And with this, how does it change the security landscape? And that is where this entire discussion comes in from a shift left security and the DevSecOps standpoint, right? So let's look at it from this point of view, right? Traditionally, the developer would build an application in the traditional world, in the legacy data center application world, right? Build their application, they would write a code, give the compatibility matrix and the application package to a developer, to the operations team, and the operations team would then deploy it in the data center, and everything works fine, right? And this methodology has worked for a very long time, right? And in this scenario, if there is a security misconfiguration, or if there is a particular what is a vulnerability that has been identified in a resource, right? There is a particular SOP which has been predefined, working well for years, saying that test it in staging or UAT environment, and once everything works fine, in the next downtime, apply those patches or the configuration changes into the production, and then the entire issue is taken care of. But in the newer world, right, where app modernization has come in, the adoption of cloud and containers and serverless has coming in, right? We saw the entire process of how the software development happens, how IAC comes into play. With this entire scenario coming in, right, there is a new team that comes into the mix of the deployment aspect, and that is the DevOps team, right, who are responsible for modernizing the entire rollout of application. Now, in this scenario, the developer would build his code, okay, but instead of creating a package and a compatibility matrix, what he would do is he would apply it into his GitHub. And once it is applied, it goes through the CI/CD process, where everything is automated, right from your build to unit test, integration, staging, production. And once the deployment, once it is ready to be deployed, right, it using the infrastructure as a code and the rest of the application codes, right, it gets automatically deployed into your cloud environment. Now, in this scenario, okay, most of the communication that happens between the multiple teams is using some kind of a collaboration tool, right? It could be Jira, Slack, or Teams, or any tool that is integrated across all the three different stages of the organization structure, right? And this is where all the communication that happens in terms of what needs to be done, how the teams collaborate with each other. But in this scenario, if we see a similar situation, right, where there is a cloud misconfiguration, or a security group which is not configured correctly, or an S3 bucket which requires a configuration change, right, or maybe it's accidentally exposed to a public network which should have been private, what would typically happen, right? The operations teams are not going to change this, primarily because if something is changed in the operation stage, right, the resources that were deployed as per using the infrastructure as a code, the state table goes completely out of sync. That breaks down the entire purpose of having an automated deployment process. Now, in this scenario, if an error is detected or a misconfiguration or a threat or vulnerability is detected, right, the information is sent to the software, to the developer team, right, using the collaboration channel. And then the developer would go create the code, okay, or reconfigure the code to correct those challenges, right, in terms of, if the S3 bucket was publicly exposed, the private bucket, then the configuration changes are done in the IAC code. And once everything is done, right, it is reapplied into the cloud environment. And that is how the automation kicks in and makes sure that the end-to-end process, right from detecting all the way to the cloud, is completely automated and completely in sync. And this is where the new set of requirements start coming in. Imagine the situation where developers have to re-go or redo the entire IAC code every time there is a vulnerability detected or a misconfiguration detected, which is a massive task, right? Because developers keep moving from one project to another, and if they have to rework on the existing one, it definitely does not work, right? And that adds in a lot of friction from a security point of view. And this is where, as a partner or a trusted advisor to the customer, it becomes important for you to have a conversation with the customer to make sure that the infrastructure as a code, when they are created, when they are built, it is actually doing the security scan way early in the entire life cycle, making sure that whatever code that has been created in the development stage has all the security taken care of it, right? Typically, if you today talk to most of the CISOs or the CIOs or the CTOs of the world, they would be talking more about security as a code or policy as a code, and that becomes an important aspect of the entire security design, and that's what helps you build the DevSecOps environment. Now, just looking at what is changing from a security landscape, right? From a traditional point of view, the code security or the application code security was always the responsibility of the developers, right? Once that is taken care of using the SaaS dash checks, making sure that there are no vulnerabilities, everything else used to fall under the operations team from a security purview. Now, with the shift in the application, the compute, and the infrastructure modernization, a lot of security contributions is now coming from the DevOps and the developer teams, right? Fixing the vulnerability of a container, cloud configurations, misconfigurations from an IAC code point of view. And from the operations point of view, while the customer is, or the SecOps team of the customer is still responsible for the security of the cloud, the contribution comes from multiple teams, and that is actually defining the new trend of shift left security. And this requires you a completely new set of capabilities to enable your DevOps team, to enable your developer team to adopt security much early in the life cycle, making sure that security by design is part of the entire life cycle that the customer is looking at from their deployment point of view. The second thing which I wanted to quickly touch upon from a challenge point of view, recently what we have seen is, there has always been a way to secure your applications. With the web-based applications, which has been running for over multiple decades, right, has worked well with a particular security mechanism. It's a 3-tier application model. And whenever there is a security requirement to secure your web application, the traditional approach is to add a WAF, either a cloud-based WAF or a on-premise appliance-based WAF, put it in front of your web application. All the web traffic goes through it, and you secure it using the security using the web application firewalls. And as the threat vector increases, okay, you keep adding next gen firewalls, the IPS threat prevention capability to make sure that all the security threat vectors are taken care of. This worked well from a 3-tier architecture model of view, but as we progress to the new age applications, the methodology or the idea is to make sure that you have a much more security. You have a security which is much more closer, right? Primarily trying to address the challenges of saying that the traditional mechanism may work for the existing application, but for the new applications, it is because if a threat penetrates into your environment, it becomes even more important to make sure that all your applications are secure, right? Primarily because the security mechanism is sitting outside the environment. It does not have a view of what is happening inside the compute environment, where there is absolutely zero security, and that is requiring for a completely new look into a security thing, right? Similarly, from a network segmentation point of view, there is a requirement for all the applications to talk to each other in a much simpler way. uh, uh, you know uh, uh, and the And the requirement and the challenge out here is primarily to make sure that the DevOps can adopt segmentation capabilities, adhering to the compliance challenges and an increased risk, right? While all of these capabilities are required to be delivered, applying it from a tool point of view can actually be pretty much complex and complicated, right? And that is why there is a requirement to relook at security completely from a different perspective, primarily because if you have siloed tools taking care of individual requirement, there is limited visibility, there is lack of integration, and there is lack of end-to-end automation, which is specifically needed from a cloud point of view. Now, from a security point of view, what Palo Alto brings onto the table is primarily the complete end-to-end security, right? The first, starting with securing your cloud infrastructure using the API environment, making sure that all the compute resources that are part of the services that are part of the cloud deployment are completely secure from a runtime security, from a vulnerability compliance point of view, and then finally making sure the perimeter is completely secure with the next-gen firewall capabilities. This predominantly covers all the different threat vectors of the security. And to make sure that all of these security components do not just work in a silo, this XOR platform, the Cortex XOR platform, make sure that they are all tied together to provide you with an integrated security approach for your cloud. Just to highlight from a partner point of view, right? When you engage with a customer, you need to take care of all the different aspects on a single platform. Palo Alto Networks provides you the capability of DevSecOps, which is the shift left security, integration with CI/CD pipeline, ISC code scans, and as the application moves to your runtime, cloud security posture management for your cloud, making sure that you can look into the misconfiguration, detect the vulnerabilities, detect the threats in your environment, and then taking it to the next level, to the compute level, where you can put across compute, host, container, and serverless security, the cloud network security, and the cloud entitlement management, right? From a partner point of view, when you start engaging with your customer, you have all the different aspects coming out of a single tool, which takes care of the entire life cycle and the entire stack of the application from a security point of view. I think that's predominantly that I wanted to quickly cover and showcase that how Prisma Cloud as a single platform can take care of the multi-cloud environment, private cloud, public cloud, different cloud, compute environment, and take care of all the security aspects from a single tool, which would allow you to make sure that your customer has a safe and secure journey in the cloud. Thanks, everyone. Jack, is there a question that we need to take up, or we're good?
Okay, now thank you very much. So what we are doing is we are taking through the presentations, and the questions are in the comments box. So that's fine. So so what we've learned here from Palo Alto. So hang on a sec. Let me just find out where the next speaker is. Sujit, my apologies. Right. So thank you very much, Sujit, for this the great presentation, focusing on the comprehensive cloud native security. We are still waiting for Mike, who is our next speaker. So we have got a couple of minutes whilst he joins back. So if you would like to continue, Sujit, with few more high-level takeaways, that'll be fantastic.
Definitely. So I think that would really help, Jackie. And what I will do is I'll run through a couple of slides, which I still had in my slide deck, right? So just wanted to give a flavor of what comes in as part of the solution from a CSPM point of view. The security starts right at the point of time when you start seeing all the resources. So starting from cloud inventory management across your multiple cloud, configuration and compliance monitoring, and anomaly and alerting capabilities brings in the CSPM portion of the module. From a compute security point of, right, it does a comprehensive security, right from vulnerability management, compliance, CI/CD integration for your DevSecOps and DevOps integration, the runtime defense, which uses static analysis, machine learning, predictive modeling, integration with threat Intel Cloud, to make sure that you have a comprehensive security across all the three variants of compute services, right? Whether it is VM, serverless, or the container environment, and that ties up it predominantly together. And then probably this is the last slide I would just like to leave it with, and that is making sure that in the entire life cycle, at all the stages of the application life cycle, right, you have the security coming in, right? Like in the shift left security, do the CFT scan, the Terraform scan, the YAML manifest for the containers, do the entire policy guardrail right at the time when the code is written. Moving into the CI/CD stage where you can do the vulnerability scanning and the compliance, and making sure that you have the capability to enforce all of this during the CD stage. And finally, in the runtime, tie them together with all the capabilities that are required, right? CSPM, cloud workload protection, threat prevention, WAF and the API and web application and API security and micro segmentation to have a comprehensive security structure for customer point of view.
Fantastic. Thank you very much, Sujit. That gave us a good idea, and I'm sure if audience has the questions, they can reach out. Audience, please feel free to start the chat and send the comments if you have any questions. Thank you very much, Sujit. Appreciate your time today. Now we'll just go over to our next speaker, Mike Rain, who is our APEC partner architect, and he's going to take us through cloud security monitoring and analytics. Over to you, Mike.
Thank you very much. Good morning, good afternoon, or good evening, depending on where you're calling from. Mike Rain is my name. I'm with Sumo Logic. I'm based in Singapore. I'm going to give you an introduction to Sumo Logic today and talk to you about how we're helping some of our customers at all different levels of security maturity deliver security, cloud security monitoring, analytics, and also an advanced cloud SIEM solution using our technology. So if you're not familiar with Sumo Logic, we're the industry's first and only cloud native continuous intelligence platform. So we provide different stakeholders within our customers intelligence on what's going on within their infrastructure and applications. So we do this across different functional areas. We do this across business intelligence, security intelligence, and also operational intelligence. And as we go through the presentation today, this is geared around giving you an introduction to the security intelligence offering. So that's where we'll focus today. How our technology works is that we essentially log aggregate all of our organization's logs, metrics, events, traces, and APM data, telemetry, and we bring this into one centralized location from wherever it exists within our customers. So some of our customers are running mainly on-premise infrastructure. Many of them are running hybrid infrastructure in one or more clouds using things like PaaS and SaaS and IaaS as well. And we have a lot of customers using cloud native technology. You know, they're deployed containers. They're using things like Kubernetes. They're architecting microservices-based applications. So whether data is structured or unstructured, Sumo Logic at scale in the cloud centralizes all of this information from all the different siloed repositories that customers has and turns that raw machine data, that non-human readable data, into what we call continuous intelligence for all different types of stakeholders within our customers. Today, we're going to have a brief discussion on our security intelligence. And you'll notice on the screen here that we use this concept of crawling, walking, and running. So all of the technology and all of the solutions that I'm going to talk to you today are one single SaaS solution from Sumo Logic. But in my experience, customers have different levels of security maturity. And a lot of the times in this particular space, they refer to all of these things as SIEM or even SOC. But actually, when you break it down and you understand, you know, some of the challenges that customers have, they're actually looking to solve different business problems. And those different business problems are really aligned with the security maturity of them. So I'm going to give you a brief introduction to each three of these components today. We see some customers that are beginning their cloud security journey that that are really looking to focus on audit and compliance, right? So they've either have some requirements and obligations they're looking to meet, or they're looking to try and respond to an audit and different requirements there. So we'll touch upon that. We see the vast majority of our customers really in the center section here that we refer to as cloud security monitoring and analytics, or this is the walking stage, to use that analogy. So what we're talking about here is we're really talking about taking all of the logs, all of the events, all of the different metrics that are pulled out of infrastructure across a very broad landscape and turning that into something visual, real information and real analytics that the business can use to make security orientated decisions and strategies moving forward, right? Turning that data that's stuck away in a closet, and not in one closet, but in AWS, in GCP, in Azure, in all the different SaaS solutions that the customers using, Office 365 and G Suite, in their CDNs and their WAFs and their Oktas, and all of this dispersed information. I'm turning that into something visual and something usable, combined with some threat intelligence. And then we see customers, and an ever increasing number, that have experience with SIEM. Maybe they've been running a SIEM on-premise for years, and their business is transforming itself into a cloud-native organization, right? They're reworking monolithic applications that typically live behind the firewall and turning them into microservice-driven applications. So we'll touch upon these three areas today. And Sumo Logic, just to touch upon, we were born in the cloud. So we are a 40-plus microservice-driven application, providing infinite scale, infinite elasticity, and all the kind of benefits that you associate with moving workloads into the cloud apply to the Sumo Logic solution. We're not a solution that's been VM'd up and stuck on an EC2 instance or a virtual machine or something like that. We really are a true cloud-native solution per se. So to just touch upon the audit and compliance piece. So this is typically where customers start, and a lot of customers have been through this process, but it's really about responding to compliance obligations and adhering to audit in that regard. So you'll see the different types of audit and compliance obligations that we help customers with. ISO 27001 is a big one, PCI DSS, GDPR, these types of obligations, right? We can definitely assist with. And this is just a bit of a look at what our solution looks like, right? It's turning all of that raw event data, all of that raw log information into something visual and much more consumable per se. I mentioned before that where we see a very large portion of customers is really in this cloud security monitoring and analytics stage. So what this is doing is that we have an app catalog which has hundreds and hundreds of common applications and infrastructure that customers run. Right, everything from the different AWS solutions that you see up here in the top left, to the different SaaS solutions. We just heard from Palo Alto Networks, Cisco, all the different endpoint solutions, the Carbon Blacks and the CrowdStrikes and the FireEyes and things of the world. So we see customers running this technology all the time, right? And they're not usually in any great capacity getting any level of intelligence out of this information. So our cloud security monitoring and analytics solution aggregates all of this information together, and it has a lot of out-of-the-box content that customers can just deploy without any configuration or even having to know what to look at or what to look for, and turn that into instant intelligence per se. This is an example of what some of the dashboards look like. So you'll see over here on the left-hand side that we can do things like look up addresses on a map and provide some context as to where activity is taking place from, turn data into charts and tables and graphs. We can also help baseline activity and help provide the business an understanding of, well, what is normal activity? and send notifications and alerts and things of this nature when we detect things outside what would be considered normal. We also allow customers, in particular in AWS, to benchmark themselves and their AWS deployments against having about 4,000 customers, AWS customers, that are using our platform. So from a threat benchmarking point of view, how does your AWS accounts and services compare from a security posture point of view to other AWS customers? Are you seeing more events in GuardDuty or in CloudTrail logs than other customers? Where are they coming from? And allow them to basically check their security posture against anonymized data from thousands and thousands of other AWS customers. And very importantly here is that we also provide customers with threat intelligence. So built into our platform is CrowdStrike's threat, I should say, our threat intelligence is powered by CrowdStrike. So it means any bit and byte of information or log or events that is brought into Sumo Logic Cloud Security Monitoring and Analytics will have CrowdStrike's threat intelligence run across the top of it to be able to identify, bad IP addresses right across your infrastructure and application landscape, file hashes that are running on endpoints, domains that we're seeing in your load balancers and your email logs and things of this nature. So that's where we see a lot of customers, and our single unified solution allows customers to break off that components and consume it almost instantaneously, being that we're a SaaS solution and everything that we've discussed so far is kind of out of the box. When customers have become familiar with that and have gained some maturity in that, or for customers that have a SOC and have experience in SIEM or SOAR before, we have an advanced offering. And the advanced offering works on the same logs and events, metrics and traces that we've been speaking about so far today, but it provides much more granularity, specifically mapped to the MITRE ATT&CK framework for customers that have, security maturity per se. So, where we see this technology being most prevalent is when our customers are transforming and migrating and moving their business into the cloud. SIEM is not a new domain, but typically speaking, SIEM has been a technology that runs behind the firewall, inside the perimeter per se. And we're seeing security operations change through cloud adoption, right? And legacy SIEMs were not built running inside the perimeter behind the firewall to start dealing with the massive amounts of data that things like microservices and SaaS and multi-cloud produce, right? We're also seeing that the landscape is changing. The concept of the cloud, there is no more perimeter. There is no more trusted environment per se. And, all these advancements in microservices and cloud native and serverless are fantastic from a functionality and a productivity point of view, but they're producing ridiculous volumes of machine data, logs and events and transactions and so forth. So we're seeing traditional SIEM solutions and bearers and drivers of these solutions really struggle with alert fatigue, right? These logs and the volume of alerts is no longer a human scalable problem, right? So this is essentially what we're doing here is we're providing the ability to be able to detect, investigate, and respond in a SOC security landscape or a SOC or security context, specifically to threats that come into your IT and infrastructure, and application landscape. And you'll see here that it's mapped to the MITRE ATT&CK framework per se. A good example of a legacy SIEM solution and where we see a lot of customers really struggling to keep their heads above water is just the volume of data. So, some of these statistics is taken from one of our largest customers in Australia that was running an on-premise SIEM, but in the process of migrating their IT infrastructure landscape into AWS. We saw them over a 45-day period produce around 10 billion lines of security log, right? 10 billion. That's a lot of different transactions, from everything from servers to serverless to storage to authentication to every transaction of a security context in their organization. And nearly 10 million, or around 1%, of those log messages contain some type of security signal or event that was interest to the scene. And this is what SIEM solutions do traditionally, right? They are vacuums of different events and different activity inside customers' environments, and they match them against rules, or they match them against templates of signals to see where events of interest may have taken place, right? And that's a huge amount of signals or events for a SOC or a SOC analyst to have to investigate. So being that we're running as a cloud native solution with infinite compute, infinite storage, memory, and IO available to us, we take it a little bit further. We take it to the next level. And using some machine learning and artificial intelligence, we're able to essentially group these signals together by entities. And an entity could be a username, it could be a host name or an IP address, a MAC address, these types of things. And we're able to group these signals together to form insights, or think of an insight as an investigation that we're asking for somebody to eyeball, right? Upon eyeballing such insights, they are able to determine that 95 of them had no action required. There was quite legitimate reasons why that investigation was created based on automation. There were 15 false positives, and actually over a 45-day period, we were able to reduce the number of incidents that needed time and attention from SOC analysts, down to a couple of dozen, or 65 per se. So, the context here, just to provide it maybe in a more relevant scenario or to less of a scale, this is what our solution kind of looks like. Records coming in are raw log messages. So we can see this particular customer in the last 24 hours generated 3 million lines of security log that were brought into Sumo Logic. 74,000 signals were detected. Think of signals as events of interest that were matched against rules. And we're saying that there's 5 series of events called insights that we've created into an investigation that's much more consumable for a SOC and a SOC analyst to be able to investigate, rather than having to manually sift through and correlate tens of thousands, or in this case 74,000 signals per se. I hope you now are a little bit more aware of Sumo Logic and how we help our customers solve the challenges of security in the cloud. If there are any questions or any comments, I'd be happy to take them for now.
Thank you, Mike. So with the questions and comments, team can just put it on the chat box, and if you can answer them, if they are in the chat box, that'd be fantastic. Thank you so much for taking us through, Mike, and appreciate your time. Now thanks, Mike. We've got our next speaker, Shane Luke, and Shane comes from Checkpoint. He's a cloud security architect, and he's going to take us through automating AWS best practice security and compliance with CloudGuard with the live demo. Over to you, Shane.
Thank you, Pallav. That was a nice introduction from your side there. Thank you for joining us today, guys. And today I'll be discussing on how automating AWS best practices, more looking after compliancy within the cloud, posture management, so on and so forth. I'm not going to bore you guys with slides today. It's going to be a couple of slides, and then I will go over into a live presentation. So I hope you guys enjoy the next 20 minutes with me. Let's jump into this. Now, firstly, why CloudGuard and for cloud security on AWS? Well, the first 4 points are more of a commercial perspective, how we actually sit with AWS. We do co-sell with them. We are available in the marketplace, leverage the Checkpoint on-prem credibility and sizability customer base. So customers that's already using Checkpoint on-prem can use us in the cloud as well. And it looks and feels exactly the same how it will be on-prem. It will be in the cloud as well. Where I want to focus today is more from point 4 to point 7, where it's the enterprise-grade security close capability gaps versus the native security offerings. Yeah, so AWS does offer you with a security, some sort of security, but is that advanced threat prevention that's needed, that zero-day, that sandboxing technology that's needed. Because at the end of the day, if you get a patient zero within your cloud environment, it's all over. And we can reference a good case study that happened 2019, which was Capital One up in the States, where they were compromised due to one small misconfiguration. Then point number 5 is enhanced cloud guard capabilities using the AWS management consoles as well. Now, that's another thing is how we natively integrate within AWS. Then the deep technical integration with key components with AWS platforms make your life easier. So we integrate with Security Hub. We integrate with cloud, AWS VPC logs and all that stuff. And all of those information that we get within those native cloud APIs, we can ingest into our platform and it will enrich the data. And then the last point is to validate as best practice by AWS with a co-branded architectural documentation. So we actually sit with AWS and see what is the best way to secure your cloud environment. How can we secure your hub and spoke type of deployment or gateway load balancers? Where's the best place to put your gateway load balancers, and making sure that you've got an advanced threat prevention in that regards. Moving on. Now, I just quickly want to touch base what's CloudGuard and where do you put our solutions. Now, firstly, the first one I want to focus on is CloudGuard posture management and CloudGuard intelligence. Now, you guys will see it's overarching the cloud environment. So we're not sitting inside of cloud. This is just sitting above. It's agentless. We do not deploy any agents within the cloud environment inside of AWS, and we utilize the native cloud tools. Intelligent pieces where we use VPC flow logs, we use identity, seeing which IAM user did what inside of the environment, who deleted the EC2 KP instance, or who deleted the S3 bucket. Then moving down a little bit is your cloud security, network security on the perimeter. So on the perimeter, you'll deploy your cloud gateways, your network security. This is where we do that advanced threat prevention, sandboxing, making sure there's no patient zero coming through into your network. And then inside of the cloud, this is where we start doing the cool stuff like web application control, CloudGuard AppSec, where we do WAF and OWASP top 10 and anti-bot connections coming into your web applications. Then moving a little bit to the right is your container workload and your serverless workloads. So we do protection for your containers and serverless. And I say protection, not just detection, we actually do prevention on the fly here. So we look for behavioral, if your serverless is not doing what it's supposed to do, runtime prevention, looking at your serverless, what's running on it, what calls did it make, when APIs did it, when network did it go. Now, with all of this is we totally align with the Gartner CNAPP model or the Google 4Cs. If you want to read up in those, that's a very good document to read up on. And this the cloud securities that we try to solve here, or the challenges that we try to solve, or not trying, that we're actually solving, are misconfiguration and configuration drift with the CloudGuard posture management, which I'm going to show you guys today with a live demo. Now, CloudGuard posture management, what it is, as mentioned to you, it's an agentless SaaS solution. So we do not install any agents within the environment. Not only that, we've got instances in Australia and in Singapore. We've got local instances. So if there's customers that's worried about data sovereignty, it should not be an issue, because we purely just look at metadata. We can't see what's inside of the packets. All we can see is source and destination, IP and ports. That's it. But however, those instances can be local in Singapore or in Australia. Now, what do we see? Well, firstly, it's complete visibility within of the cloud assets. So we can show you exactly which security group is talking to which security group. You've got like 9 public IPs talking to a common security group, and this security group can talk to this database security group within the network. Research compliance frameworks. We've got about 37 odd different compliance here, ranging from NIST, HIPAA, ISO 27001, CIS, and you can create these guardrails or these frameworks and making sure that your business or your company stays within those guardrails. And then the last point I want to talk about is the auto remediation, where actually with step 2, you create those guardrails or those frameworks, and when that's done, when somebody steps out of the guardrails, the cloud bots can actually go out and auto remediate that environment. So automatically go and pull it back. So for instance, somebody spins up a S3 bucket and they forget to enable encryption on it. The cloud bot can actually go out and say, cool, you're allowed to have an S3 bucket, but you need to enable encryption, but I'll do that on your behalf. So that auto remediation, getting rid of that misconfiguration. So if we use that use case study or that case study again from Capital One, where that misconfiguration is out of the security group, the cloud bots could have prevented that attack from happening within Capital One. But let's go into a demo. If you guys will, let's jump into this. Now this is CloudGuard Native. CloudGuard Native is a SaaS-based application, as mentioned to you, and this particular one that I'm running on is in the States, but we've got instances in Ireland, States, Australia, Singapore, and the UK. So we've got instances at all of the major AWS hubs within the globe. But let's dive into this for the last 13 minutes here. As you guys can see, this is a multi-cloud environment. Not only can we look into AWS, but we can see Azure and GCP and Alibaba. But not only that, we can see Kubernetes as well. Nice thing of this is Kubernetes can be on-prem or in the cloud. And then this pink little cloud here is our shift left piece. That's our CI/CD pipeline. This is where we do source code scanning. We do image scanning, making sure there's no vulnerabilities or malware embedded inside of the images, or there's no root keys embedded or passwords embedded inside of the source code or images. But moving along, in this environment or in this tenancy, we've got like 70 odd different accounts, multi-cloud, and we are protecting about almost 14,200 assets. Now, what's an asset for us? An asset for us is anything that's inside of a cloud. So it can be a GCP IAM role, it's Kubernetes images, AWS regions, or VPCs, Lambda functions, Athenas, replica sets, Azure role assignments. So basically anything that we can see within a cloud environment is a protected asset for us. Not only can we have this kind of dashboard, we can even provide you with a SOC kind of dashboards. This is where we use threat intelligence and threat hunting, and we can show you malicious traffic coming in for the last 24 hours. The total malicious traffic bandwidth inside of this environment. Service that's compromised, or suspicious DNS packets within your environment. On top of that, we can look into vulnerability. So if you're using a vulnerability scanner inside of your cloud, like Tenable.io, we can integrate natively with Tenable.io, and we can show you vulnerabilities within your cloud environments. As mentioned, this is agentless, so we can't see inside of the virtual machine, but with the use of Tenable.io, we can then see what's happening inside of it. On top of that, vulnerabilities inside of your containers, and then vulnerabilities inside of the code. And then the last one is suspicious users who's logged in without MFA, or who's trying to log in from a malicious IP. Number of logins that failed into the AWS console. So stuff like that we can show you to see where is a possible misconfiguration in my environment. But not only that, we can also do compliance trends. So this is more for management. If they want to see, yep, cool, on the 1st of August or the 26th of July, I was running at 71%, and over the last couple of months, it actually came down, and now we're running at 71% as well, or 71.6. Why was there a dip inside of my PCI DSS? So you can have that trends perspective to see what's happening within the environment. However, I don't want to spend a lot of time here. I actually want to show you guys the posture side of things. I mentioned we got like 37 different old compliances, but not only that, we also run a 1,500 rules out of the box. Now, what's a rule? A rule is a heading, a description, and then the most important part is a remediation. How can we fix it, or how to fix that problem? Now, this is what we've got for AWS. As you guys can see here, we've got NIST, PCI DSS, and GDPR, and CIS. Now, I want to focus on the CIS one. Yeah, so I'm going to click on CIS, and this is what CIS is. CIS consists of 25 rules, and within that, I mentioned it's a heading, a description, and then the remediation. Now, if you guys look closely here, this remediation is not a checkpoint remediation. It's an AWS remediation, or an Azure, or a GCP, because at the end of the day, it's their cloud. They will know the best way to fix the problem if you fail that compliance. And then to create custom ones, or to create this rule set, we've got something called GSL, Global Security Language. But let me run this one quickly against my environment. So I'm going to run this bespoke. I can run this against my entire environment, or I can just type in prod. And if I type in prod, I will run this against my prod. This takes a few seconds to run. And after a few seconds, it will show me an environment, or will show me a report. If I was failing, did I pass? Where did I fail? Where did I pass? But also not that. If you guys keep remember, I mentioned there's 25 rules. And I actually want to talk about that once this report's shown. So just give it a couple of seconds. Come now. Then you just love the demo gods. Cool. So let's just quickly refresh this page. We'll run it again. So click on posture management over here. Rule sets. Already got it run here. So let's just jump in here. So run assessment. Run against my prod. Run it. So let's see. Cool. Here we go. Now, here you guys can see here's the report. I mentioned there was 25 rules. We ran over 5,000 tests. How's that possible? Well, we test every single entity within this environment. And to show you guys this, we're looking at load balancers, Kinesis, S3 buckets, IAM users, security groups, CloudTrail, RDSs, Lambda functions. So this is all of the assets we test inside, or entities we test inside this environment. We got a score of 72%, and this is all the ones that we failed. Now, I want to focus on a particular one, and the one I want to focus on is a ensure security group, no security group allows ingress default internet. So yeah, if I open this up, here we can see expanding this, description, and then remediation. So basically what this is saying is make sure there's no security group that's allowing a default route coming in on port 22. Over 300 security groups were tested, 32 is non-compliant. With that being said, these are all of the security groups that's not compliant in the regions where they are sitting, as well as on what part of the VPC they are. So from here, we can go to AWS and go remove that default route coming in on port 22, or we can actually just by bespoke say, Mr. CloudBot, can you please go and remove that for me? Now from here, I can say, EC2, there's a particular one that I was after here. Security group. So security group rules delete. So here we can say, please go and delete that security group for me, or please remove that default route for me, and the CloudBot will actually go out. Or we can actually go into the security group from here. So literally going to the security group and actually delete it from here. It can be done as well. So if I click on this, it will open up a new tab. As you guys can see, we're still part of the same SaaS environment. And we can actively change the security group's settings and configurations from this portal. So as you guys can see, we're inside of security groups, and I can go into full protection mode. And from here, I can say edit. Also, let me go one back, sorry. I can click on edit. And then I can change this. So literally, or I can say delete. So no need to go to AWS to go and do this. You can do it within CloudGuard native. Now, the other one I want to quickly run over you guys because I've got 5 minutes left here is creating custom rule sets. Now, to create custom rule sets within any cloud provider, you need to understand scripting, compiling code, Python, and upload it. And that it's tedious and it's a long process. Well, with us, it's very easy. So to do a quick one, I can say an instance should have tags that contains a value that's equal to def add close the bracket test. So now I'm testing a very simple rule against my production. I can test this against all of it, select all, or certain parts, and immediately it'll give me a result. But let's say you didn't want to test dev, you want to test ops or prod for production, you can just change that to prod and you can run the test again. Now, the last bit I want to show you guys is how long will it take you guys to drop a diagram of your cloud environment, which VPC is talking to which VPC or security groups, that visualization. And this is where we're actually quite strong in that part. Now, within Configuration Explorer, you guys can see we're a multi-cloud environment. I'm going to focus on AWS Prod. AWS Prod is a multi-region, and Oregon is my biggest one. So within Oregon, I can then see all of my VPCs in here. Now I'm going to click on my main VPC. It shows me VPC peering. But not only that, we can even show you if that VPC is part of a legend sitting on the wrong side. But anyway, what we can show you if that VPC is part of the same cloud account, if it's from a different cloud account, is it outside of a cloud environment. Now from here, I can go one level deeper. And this is a swimming lane feature we can show you here. And within here, we can show you that security groups are exposed. So if they fall inside of a DMZ, they are quite exposed to the internet because it's based on security group. The more secure they are, the more to the right they'll move. I can then go in here and say, well, there's nine public IPs, static IPs that's coming to my security group, common security group. If I click on it, I can see exactly that these 9 IPs are talking to my common security group on this port numbers. But not only that, the internet is talking to it as well on port 80. So once again, it gives you that visibility. Yes, this can be done with an AWS, but not on a visual stage. You actually have to go write it down and go draw it up yourself. Not only that, we can show you if there's internal communication to internal security groups. Then the last piece I want to talk about before my time runs out is asset view. So now we're going one level deeper. So we've shown you VPCs, how the VPCs are talking. Then we've shown you how the security groups are talking. But here is now the assets. So for instance, 5 public external IPs, and these external IPs are talking to all of these environments. So we've got the Tenable demo over here. Sorry guys, Tenable demo, a database one. Oh, why do we have got the database instead of my DMZ? That should not be the case. So here we can see sources. Yep, we can see the internet can talk to it. Okay, that's interesting. And then if I go to Ethernet over here, it's got a public IP address to it. Now, this can be part of the design. However, we can also create the rule saying if a database has got a public address, alert me. The cloud bot can go remove it, as well as it can come over to Clarity and see exactly which asset is talking to which asset. I believe that's my time. If you guys got any questions, please reach out to me or to the wider Westcon team. I'll be there to answer your questions. Thank you very much. I'll give it back to Polaf. I think you're muted, Polaf. Nope.
All right. Can you hear me now?
Yep. I can
All
hear
right,
you.
great. Thank you, Sean. Thanks for your time and a great presentation. If you have any questions, audience, please reach out to Sean or please put it on the comments box and we can help you with that. Our next speaker, thanks, Sean. Our next speaker is Stefan Montre. So Stefan comes from Mirantis. He's a cloud solutions architect, and he's going to take us through everything you need to know about container security and standards. Over to you, Stefan.
Thank you, Pavel. Hello, everybody. I will talk today how we can protect our deployment and data on container, and especially with the FIPS certification and the STIG security group. So my name is Stéphane Montry. I'm working at Numantis as a solution engineer or cloud architect with a strong background in cloud architecture and container and Kubernetes orchestration layer. So first of all, that this ecosystem and Numantis tries to win on the market. The whole goal of Numantis is to simplify the cloud native infrastructure. So for those who know Numantis already, Numantis is coming from the OpenStack ecosystem. So we a big, huge contributor in the OpenStack open source community. And during this last 10 years, Numantis really aimed, to simplify the access and usage of OpenStack because OpenStack is a complex environment. We provide our solution stack and also some managed services for this stack. So what we did for OpenStack previously, we are now doing it for Kubernetes and container. So why simplifying? Because we want our customer to be successful with Kubernetes, and for this we have three main topics around this. The first one is the choice, so meaning that we want to let and give the choice to our customer in how they want to deploy, which component they want to deploy. Simplicity, because again, Kubernetes is a complex topic, so we want to make it simple for our customer. And of course, and this is the topic of today, with security. At the end, what we aim to provide to our customer is really to be able to deploy any container on any cloud, everywhere, with the same experience, whether it's on-prem environment or with public cloud like AWS. Now, if you look at the overview of containers and what containers means for Numantis, so what you can see is a different layer, a different stack that you mostly know from different cloud providers or vendors, is that we will rely on some infrastructure, which obviously can be AWS, the operating of the machine, bare metal or virtual machine, and we will put on top of that our container and Kubernetes stack. What do we have? We have first the runtime, which is the component that enables you to run containers. And obviously, our Kubernetes engine, which is our Kubernetes stack, will rely on this runtime in order to run your Docker images and securely, and we'll see that. Then on the left, we have one of our component, which is Container Cloud, which is also basically deploy on AWS, which will help our customer to create and manage the lifecycle of our clusters, and also, again, in a secure way, meaning that we bring all the component and all the security component live in order to run our containerized application. And more importantly, you'll also need a private registry in order to store the image and secure the image that you will deploy in your environment. And what the last layer you see on top is Lens, is our open source solution, which enable customers to access and troubleshooting any Kubernetes cluster, whether it is Kubernetes or something else. For example, you can easily use EKS cluster with Lens. And the goal of Lens is really a Kubernetes IDE in order, again, to simplify the access to cluster. And we also provide capabilities to share cluster between people in a secure way. So what you do today with Lens, especially, is really the capability to connect to a backbone, which is hosted on AWS, and to be able to authenticate to this backbone and then share clusters without having to, to copy the config file, etc. Because we create a secure layer, a secure channel between the cluster and the people who have access to that cluster. With this all the stack, again, the goal is really to make it simple, to deploy it fastly, so to be fast deploying this cluster and managing this cluster, make it reliable, because we have all the solution to govern this cluster from the beginning and to the day two operation. Bring security layer in the infrastructure. So of course we rely on security, which is already in place by the cloud. And we put on top of that security on the runtime and security also in the registry, because we will also be able to scan the images for any vulnerability. And of course, because the goal of Kubernetes is also to be able also to make it bigger and bigger in the way we deploy the cluster. And of course, again, the goal of Mirantis is really to be the DevOps as a service platform. Again, we have this infrastructure layer. We rely on some partner ecosystem with a container as a service platform in order to provide the customers the experience of cloud native development and cloud native operation with, again, secure runtime, secure registry, the engine which will manage to the Kubernetes engine. Of course, we still provide again also the OpenStack environment. And then in the middle of this, Container Cloud, which will manage all this environment, whether it is containerized or virtualized, and lens in order to ease the access to any cluster and debug any cluster also for the developers. Now, what does it mean in terms of CI/CD and secure supply chain? Because where we want to make different for our customer in really being able, to attach in any part of the CI/CD process at the beginning, where we I see some issue. Let me have a question. Yeah, Lucky. Okay, I'll continue.
Yeah, please continue. That's great. Thank you.
Okay.
I don't know if you're having an issue with your headset, because it's coming out intermittently with a break in transmission.
Oh, okay. Let me try to change something. Is it better now?
Perfect. Please proceed. Great. Thank you.
Yes. Okay. Okay. So I was speaking about the secure software supply chain, where we bring these features about security and the FIPS certification regarding the container runtime. And this is one of also the key point when you look at Kubernetes, because you need to secure the way you deploy the containers. You need to secure the way you store the images. And this is important also because we then bring the capability to enforce which image will be deployed in the cluster, by defining some rules in, for example, if my image has more than 3 critical vulnerabilities, I won't be able to, I won't be allowed to deploy the image in the cluster. And this is possible because of the security we bring into the container runtime. And of course, all those layers will be activated at each step of the CI/CD process. And after that, we will also bring some capabilities at the runtime level because we will integrate with some security solution like Aqua Security, Navigator, and some others in order to also provide these security capabilities at the runtime level. So when your containerized application is running in the cluster. Now, if you look at a bigger look in the security control that we will apply. So first of all, again, it's really on the developer side and operator side as well. So the developers will build some application, whether it's microservices or traditional application or third-party application coming from software vendors. The goal is to really scan these images with the registry and during the continuous integration, because will also help in securing the code directly. You get your private image registry, so the image will be secured. And when we want to move to production, will also enable a promotion policy directly from the registry. So meaning that you'll also only promote. So first of all, the image that are secured, where you are trusting the source of the image, and then you'll be allowed to deploy this image in all your target cluster. Again, the Kubernetes platform will be able to work on any kind of infrastructure, whether it's public cloud like AWS or on-prem, virtualized, etc., etc. Now, I wanted to make a small focus in the certification and why it's important also to comply with this regulation. The first one, which is quite interesting, is that the FIPS 140-2, which is coming from the Federal Information Processing Standard, and which provide basically four levels of security, starting at level 1, which is really the least level to a full complete hardened system, but also another one. Yeah. What is important to understand the FIPS certification is that FIPS provides some cryptographic module. So in order to bring some encryption of your data at rest and in the movement also, and in Kubernetes distribution by default, you will find this FIPS certification at the runtime level, basically. So we see it mainly with government agencies or customers that are facing some regulated industries like finance, telco, or healthcare. And finally, which is interesting, is that we see customers looking at this certification also to bring the best level of security in the environment. So even if they are not subject to the regulation, it's a good best practice in order to bring the most security possible in the environment. And if you look at the Kubernetes portfolio, so the runtime is gains the FIPS certification, and then of course our Kubernetes distribution, which is Kubernetes Engine, will leverage this certification, and we also provide a small lightweight Kubernetes distribution, which is named K0S, which is open source, free, but which you can also deploy as an enterprise distribution, and which will include the FIPS certification by default. Then the FIPS certification brings to customers the capability to encrypt sensitive data, to protect the operation, of course, and also, and which is really important, is to reduce the attack vectors, because as you know, containers, Kubernetes are also bringing some new surface of attack, and it's important also to cover these new surfaces. So of course, we always get this certification, which has been renewed during the last summer, and the goal is really to provide some secure key management in order to protect your data at rest and also in the movement, and really secure all the communication you will have in your platform. Also, beside the FIP certification, we have the STIG for the Security Technical Implementation Guide. I won't take that much time on this one, but which is really interesting is that this kind of implementation guide that really provide some best practices based on a checklist and some questionnaire and guidance on what to implement for the security. Again, it's really related to government agencies or companies that are moving in regulated industries, and the goal is really to get all the best practices to be sure that nothing has been forgotten during the security checklist. But it's also a long process and a long approval period in order to get this certification. And the goal for us is really to be aligned with the industry standard for security, in order again to reduce all the different surface of attack that our customers are facing, and also our customers really need to be compliant, and then we help them to support all this compliance initiative. You find several STIG, and so a lot of implementation guide are open out there, and it's really the way of saying, okay, what do I need to do to provide some security on my platform, and I will just check this implementation guide in order to get all the information. There are some example on this slide. For example, the etcd, which is the art of Kubernetes, must use TLS to protect the confidentiality of data. The scheduler must have some security binding. There's no SSAG service running on the node, etc. So there's a bunch of list of some items that you can easily operate and use in your environment, which is really important. And as a summary, what I really wanted to highlight in this presentation is really that. So first of all, we provide with Kubernetes and the Kubernetes engine on AWS some verifiable security. So because security is really a core part of our product portfolio, because we secure the runtime, we secure the images, and we comply to really high regulated certification like the FIPS and these are STG. And there's another one which is really important, and it's coming also from a US agency, which is named the Kubernetes Hardening Guide, which is also a huge document giving some good practices and good example of how to secure and to bring the highest level of security in your Kubernetes environment, especially when you are deploying environment on public cloud like AWS. I'm done for what I wanted to present. If you have any question, feel free to ask them.
Thank you, Stefan, for your time, and appreciate you taking us through in detail. Look, if people have any questions, please reach out to Stefan or put it on the comments box. Appreciate your time. Thank you very much, Stefan.
Thank you.
And now we are off to our next speaker, Eric Rennie. Eric comes from Cisco, and he's the Regional Senior Technical Solutions Architect for Cybersecurity, Analytics, and Cloud Workload. And he's going to take us through protecting your critical workloads with Cisco Secure Cloud Analytics, and it's going to have some video as a demo. Over to you, Eric.
Yes, thank you. Thank you, everybody. Yes, we're going to go through very quickly in this next 20 minutes, a couple of slides on our view of secure network analytics, and then I'm going to follow off with a quick demo. Now, just want to make sure
Eric, yeah, you need to just go into full presentation mode on your, okay, there you go. If you can just go into full presentation mode, and I can bring that up. Thank you.
Yeah. Could you see that now? Just want to confirm that.
Perfect. Please proceed. Thank you. And you can just give me the verbal cue for the demo. Thank you.
Okay, will do. Yeah, so, yeah, sorry, start again here. So, yeah, Eric Rennie, work for Cisco, work in the secure workloads and analytics unit within this organization, covering the region, predominantly looking at the analytics protection of workloads in AWS. And we'll cover on the next couple of slides on doing that. Okay, so just like I said, a few slides to introduce you before we do the demo, because that's going to be the more interesting stuff. So secure cloud analytics, what we're doing here is we're taking native cloud telemetry data. So we're taking in AWS, from AWS, the VPC flow logs. The flow logs is giving enough information for us to do our analytics on, as we'll see in the slides. We can also deploy what we call on-premise sensors, lightweight sensors, they're lightweight VMs, where we can actually pull information from your more traditional on-premise networks. So the beauty of that is we can actually combine the both together if you're in the stage of moving between on-premise into the AWS cloud environment, for example. And the whole concept of what we're doing here with Secure Cloud Analytics is about providing visibility. We're giving you visibility within your cloud workloads, or even on your workloads on-premise in the traditional data center environment, to give you that threat detection and knowing, for example, if you're compliant with your networks or not. And we do this by what we call entity modeling or machine learning, as we'll see in the slide coming up. And it's all about really visibility if you think about it. This is what we're doing with Secure Cloud Analytics, as we call it. One of the key concepts that we have within Secure Cloud Analytics is actually on this slide here. The dynamic entity modeling is what makes this a bit different from other type of products. Now, on the input, you see things like IP telemetry, enhanced net flow, DNS snooping, for example. That's just showing some of the feeds. We don't need all of those feeds, but the more feeds we have, makes us more obviously accurate in our modeling. That entity modeling in the middle is the key, or I call it the secret sauce to the solution. It's using machine learning, using that information, and it classifies every entity, i.e. every device, every workload, every EC2 instance, every NAT gateway, whatever the device is, any entity, into 5 categories. It bases them on a role, a group, consistency, rules, and what they call forecasts. And if I just give you a quick example, what I mean by role, for example, is if we detect an entity on the network and we try to work out what that role is of that device. So let's give a simple example of a printer. If I see it acts like a printer, it's consistent with other printers that behavior, then we know the role of that entity is a printer. Once we know the role of that particular entity, that makes it easiest to start to classify if that behavior is correct for that entity. We know what ports and protocols it should be using, because that's consistency with the other printers. We can also know who it should be talking to internally, and should it be talking externally, for example. And we can forecast what that behavior should be. So that adds a lot of weight to us, that modeling or that machine learning that we do. Some of the other stuff here, just very quick overview. So once we model that entity, we're actually going to baseline its behavior. Remember I said we're all about baselining here. So from day 0, we have what we call 30 plus detections active. We don't activate every single detection from day 0 for obvious reasons. If we did that while the system is learning or baselining, we would have a lot of noise in the system, and we don't want to do that. We don't want to overwhelm our security operations personnel with a lot of noise, to be honest. By the end of the baselining, we have 110 plus and growing alerts already activated. So what we're going to do when we first see that entity is what we call discovery and learning. You see here. So we're learning about that. We're looking at the IP address, who's it communicating with. We're going to classify the role. So, hey, yep, that's in this particular example, this is a database. We've identified as a database server. We see the traffic that it communicates with. After the 36-day baseline, all those alerts are now activated and ready to fire on what we're looking for in that behavior. Then we monitor the entity as we go along, look for its normal behavior. Who does it normally talk to, for example? But when we see it then start to talk to, for example, a new external connection, And that new external connection, maybe it's outside my VPC, it's connecting into a geographical location we've never connected to, and it starts to transmit a lot of traffic. We want to know about that. That's an anomaly. That shouldn't be happening. And that's when we generate an alert. Okay, so that's what we're all about. How do we connect in? Very simple. You have a SaaS portal, and we'll see that a little bit of that in the demo coming up. The SaaS portal is actually based in AWS, Cisco's version of AWS, or not version, Cisco's part of AWS. The portal is there, the engine is there as well, so it's all cloud-based. We use the APIs effectively to connect into your Amazon account. It's just a matter of setting up the right identity access management credentials and roles, and that then gives us access into that account. And in that account, we can collect what we call the VPC flow logs that we're collecting from each VPC that you're interested in, either from your S3 bucket storage or from CloudWatch. So there's several ways we can consume that. Once we consume that, we'll pull those VPC flow logs into our engine. We'll process that and start to track those anomalies and those behaviors and baseline those entities on that network or within our VPC. With some additional configuration or an extra permissions, we can also augment that information with information from, for example, CloudTrail or GuardDuty or Immune Inspector, depending on how much additional context you want from that detection and response. In architecture, very simply, I'm showing a hybrid here. In the hybrid environment, obviously the top is what we traditionally do. We're connecting through an API, collect the flow logs from the S3 bucket and process those. Obviously, you enable the flow logs per VPC, and I'll show you that on the demo. Very simple, not per workload, not per subnet, per VPC. So it doesn't take very long to do this. It takes about 15, 20 minutes to get that up and running and sending data into Secure Cloud Analytics. Obviously, if you've got a hybrid environment like I'm showing here, where you've got still maybe a main office or some branch sites, we can still get data from those guys by deploying that SCA sensor or that lightweight, effectively virtual machine on premise. It can consume ICE logs, NetFlow, span, firewall events, all on one little small appliance. It's going to basically slice that data up and send basically IP metadata through that secure tunnel into the cloud engine and be processed. So it can process both types of information, which is kind of key. And now we're ready for the demo. Before we play the demo, I just want to explain what I'm going to demonstrate first, because it may be not obvious. In this particular demo, what I'm going to show is what I call response and remediation. We're going to see Secure Cloud Analytics monitoring my Amazon EC2 instance, and we're going to show how Secure Cloud Analytics generates an alarm, sends that to something we call SecureX. That's like our SOAR++ or XDR in Cisco world. We're using that SecureX as the glue, as our remediation engine. That's going to send a message to our secure workload product, who's then going to do a policy change on that EC2 Amazon instance. Now, that Amazon instance, all it is a Windows 2019 instance that I've spun up. And we're just going to modify the host-based firewall using our secure workload to block all traffic except for RDP, because I have to RDP in to show it as part of the demo. So what it's simulating is that a hacker has got access to that EC2 instance and is doing stuff they shouldn't be doing. And we get alerted to it by the cloud analytics. We use SecureX to, as the glue, the remediation tool, to tell the secure workload to go modify basically the host-based firewall on that Windows server, block everything except for the admin RDP access. Okay. And now if we can show the demo. Or should I show the demo? Okay. Let me show the demo here then. So here's the demo. And what we're seeing is I'm actually pinging the public IP address on my EC2 instance. Now, don't worry, that EC2 instance doesn't exist anymore. So if you try and ping it, nothing will happen. Here's me showing you in my console, AWS console. You can see it's just a Windows 2019 server. There's the instance ID. There's the public IP when it was spun up, and the private IP address that was assigned to that EC2 instance. And what I'm going to show here is that we're collecting flow logs from the VPC. Very simple to set up. There's my VPC ID. You see the flow logs, and I actually got a couple of flow logs collecting for other reasons, but I'm putting, in this particular case, my VPC flow logs into my SC3 called SWCS3 custom FL. And if you have a look at this, when you actually look at the VPC flow logs, you'll see, for example, a structure like this, AWS logs, you can drill down into the month, the day, and down to the 5-minute interval, as you'll see that. Now we're on the portal, the Secure Cloud Analytics portal. I'm looking at the main dashboard, the main landing page we would see. Now, what I'm just showing here is that on the main dashboard, we can see what alerts are happening. There's not a lot happening in my lab at the moment, to be honest. We see there's 5 open alerts. We see some daily traffic going on here. We see the number of devices or entities that we've seen in the network. We can also see the amount of encrypted traffic. So that's TLS-based traffic. We see who's talking the most on DNS, my top DNS devices. That's one of my virtual machines in the lab environment. And we can see basically high-risk countries. What countries are communicating with my on-premise and my lab environment. And we can see we get some countries coming up here. That's configurable. You can change which countries you believe are the top risks. I'm also showing that I've seen 10,000 observations overall since recording, and in that particular day, 179 that we've seen. Now, an observation is slightly different from an alert. I'm clicking on alert here. Observations feed in to the alerts. So an observation doesn't necessarily mean it's bad. It's just something we observe behavior. And some of that behavior can be bad and trigger these particular alerts. And here I'm looking at a user watch list I configured for my EC2 instance. And when we click into this, we can actually get a lot more detail on that alert. So you get a brief description of what that alert is. We get the MITRE tactics and the MITRE techniques, and you get a quick snapshot of what techniques and tactics with the full detail that is triggering. And you can obviously pivot off to that and see that. Now, what I do next is on the demo here, I go down to the supporting observations section. And remember I said supporting observation is what actually triggers the alert itself. Now, not all supporting observations are bad, but in this particular case, we see my device ID, my I03C, that's my AWS instance. We can drop down on that. We can get a lot more information. And this is where I'm now going to say, hey, I don't like what this guy is doing. And I can actually send that particular EC2 instance ID or the IP address, and I can send it off to various other tools. But in this particular example, I'm going to send it off to my secure workload or tetration, and I'm going to quarantine that user. So Secure Cloud Analytics itself doesn't quarantine anything by itself. It is not about remediation, it's about visibility. So what I'm using here is SecureX or XDR to act as the glue to do the remediation. Now, in SecureX, we have a dashboard, which uses APIs. I can pull the information from Stopwatch Cloud Analytics and view basically a panel that we're showing here. I can see my Stopwatch Cloud or Cloud Analytics stuff. We see the 5 alerts we saw on the main dashboard. The idea of this is having one place to put whatever security products you have in one place so you don't have to jump between products. Okay. And then I'm just going and showing there that I've got multiple products all hooked into the one dashboard. I've got the secure workload or tetration there, and I've got cloud. But what I'm going to go to next on the demo is I'm going to click on the top there, orchestration. Now, this is the key part. The orchestration is the playbook itself. So when I click on that orchestration, you see this. This is actually that action that I activated from the Cloud Analytics platform. Now, I'm not going to go through too much detail here, but it's searching for an IP address or it's searching for the machine ID for my EC2 instance. And depending on which one it finds, it will follow the different branch of the tree. But what it actually does is what this playbook is doing for us is actually saying, if I have this IP or this instance, then go to secure workload or tetration and place this IP address, for example, into what we call a scope called quarantine. And when anything is placed into that scope or container, which is what we're showing here, here's secure workload, and you can see my workload is there, 10.03.203. That's the guy we just quarantined from Cloud Analytics. If it meets that criteria, then basically secure workload or tertiary knows now that it needs to modify that host-based firewalls on that device and block everything. Now, this is my EC2 instance, and this is my Windows server, and I'm just showing here that I can actually ping the outside world from it because my security group is wide open. It's over permissive. It's basically allow everything in, allow everything out. My network access list is exactly the same on that. You can see now, all of a sudden the ping from my laptop to the public IP address EC2 has stopped working. That tells me that that policy has now been pushed down to this EC2 instance from secure workload. And what I'll do next is I'll reping that IP address. And what you'll see is you'll see a failure. And if I try to open up that website in a browser, for example, you'll also see that fails as well, which is what we expected to do because we basically said cut off all communications to that EC2 instance that's been compromised, but only allow this session in, which is a basic RDP session. So here, do a quick refresh, you'll see the site can't be reached as expected. Now, since this is Windows Server, I can look at the Windows firewall, the advanced firewall, and show those rules. If I refresh the rules on inbound, what you'll see is the rule at the bottom is the one that allows me into the machine using port 3389 or RDP. The other rules are what we call default rules, which allows the secure workload to talk to it, but there's no other traffic allowed. Hence, I'm not allowed to get internet access or any access out of that machine. That means we've contained that attacker. He can no longer compromise or use that platform as a area to explore or do recon attacks or steal information. Now, what I'm doing here in the final part of the demo is just actually looking at the SecureX ribbon, and I'm going to just unquarantine my EC2 instance here. You see I've got the I03 for my instance, and I'm just going to say, okay, let's unquarantine that and make sure it all comes back just to prove that it works. You'll see a message being sent to that orchestration playbook. And what we will see is we'll see from my, from secure workload here, we'll see that IP address is no longer listed under that quarantine scope. So it's no longer needs to apply that policy. So when I click there, you'll see workloads is 0 and it's gone. Now, when we go back, you'll see from my laptop, I can now reping that public IP address to my EC2 instance in AWS. So communications is back. We refresh that firewall and notice there's a lot more rules now reappeared on that host space, allowing basically internet access and allowing, it's open up the machine wide open now. Remember the security group and access are wide open on this particular EC2 instance, which is obviously bad security practice, to be honest. And we wouldn't normally do that. But for this demo, just proving the point there. Okay. And that's all I wanted to show on demo. That brings me to the end of my presentation. Okay.
Thank you very much, Eric, for taking us through the concepts and the demonstration. Look, appreciate your time, and audience, if you have any questions, feel free to reach out to Eric or put it in the comments box. Yep. Appreciate your time today. Thank you so much.
You're welcome.
So everyone, if you can please, for the last time, if you haven't already, enter the draw, spin and win. So after this, we can just move on to the auditorium for the closing session with Jason. So if you can please take your way out to auditorium, make sure that you are entering the draw, spin and win. And if you have any comments or questions, feel free to put it in the chat box. Thank you, everyone.